This is our first video on synthetic division. Synthetic division is a shortcut way to divide a polynomial p of x by a linear, that is a degree 1 divisor, that looks like x minus k. So we're going to use synthetic division to divide p of x equals x to the fifth minus 2x to the fourth minus 11x squared plus 5 by x minus 3. Now we already did that in a previous video. We did it the long way, at least I did it in the video. And there's my handwriting. So we know what the result is of that division. But now I'm going to show you this shortcut way called synthetic division. And this is something that you do need to learn how to do, and you'll be asked to verify this in testing. So here's what I'm going to do. I'm going to start out by not writing down the whole polynomial p of x, but I'm just going to write down its coefficients. So the coefficient of x to the fifth is 1. The coefficient of x to the fourth is negative 2. Now, when I use this approach, just like when you do long division, if a term is missing, you need to put a 0 coefficient in the place of that term. So if a power of x is missing, maybe I should say. So because we don't see an x to the third, it's actually 0x to the third, then minus 11x to the second. Notice that we don't see x to the first power, so it's 0x to the first. And finally, the constant coefficient 5. So this matches up to the coefficients I wrote down inside the long division box. All right, now out in front of this, I'm going to write, I guess I like to write a little box like that. I'm going to write a positive 3. Positive 3 stands in the place of the x minus 3. There's a couple reasons why we like to write a positive 3, though. One is if I change this, instead of writing minus, I write a plus here, what it does is it kind of takes care of all those subtractions that occur down the line in the long division process. It also is helpful because we're going to use this division to find p of 3. So when we write p of 3, we want a positive 3 inside. It's only this x minus 3 that has a minus. So we're going to make this connection between p of 3 and the work we do here, so it's kind of nice to write a 3 there. Now I leave a space, and I'm going to draw a line. And now I'm going to talk you through this process a couple times. I think if you just see a couple examples, that's enough to learn it. I don't think it's helpful to have like a general rule. So let me know if you need more examples. I'm happy to supply them. This one we're going to go through in detail. So to get started with synthetic division, the very first thing you always do is you just bring down that first coefficient, in this case 1. Then I'm going to multiply this times this, and now I'm going to write the result here right under the negative 2. 1 times 3 is 3. But now, in order to make this something people can watch, I'm just going to recopy all my work. So this is going to be a little bit tedious at first. Now normally you wouldn't recopy, you would just write that product there. So I brought down the 1, I multiplied 1 times 3, and I'm going to write the result of that multiplication right there. And then these two quantities I add. So negative 2 plus 3 is 1. Now I'm going to just, again, recopy everything. line, bring down my 1. 1 times 3 is 3. Add these together, I get 1. Okay. Now I'm going to multiply this 1 times the 3 in front. And I'm going to write the result right here. So 1 times 3 is 3. And then I'm going to add the two results, 0 and 3. I'll write down another line. Three, 1, negative 2, 0, negative 11, 0, 5. I brought down my 1, 3. I got a 1 here. And I guess, let's see, just to match up with my line above, I'm just going to draw an arrow into here. When I multiplied, there's my 3. And I think I'm going to go to another page. Line 1, 3, 1, 3, and now I'm going to add these two entries. I get 3, and now I go on to multiply. I guess I'm going to write one more line. 3, 1, negative 2, 0, negative 11, 0, 5. We brought down the 1. 1 times 3 is 3. Add these two, I get 1. Multiply, I get 3. Add these two, I get 3. So now we're going to multiply this result times 3. And it's going to go in the next position. 3 times 3 is 9. And then I'm going to add these two together. So I think I'm just going to write multiply. It goes there. And now I'm going to write out the rest of the process in just one step. So now I'm going to add negative 11 in 9 is negative 2. I multiply negative 2 times 3 is negative 6. I'm going to add 0 in negative 6 is negative 6. I multiply negative 6 times 3 is negative 18. I add 5 and negative 18, and I get negative 13. So again, normally, this is all you write down for the whole process, okay? So I tried to break down those first few steps so you'd have something to review. And now we got to learn how to interpret this final line at the bottom. This very last entry is the remainder. And sure enough, when we did that long division problem, negative 13 was our remainder. These guys are the coefficients of the quotient. And what you have to do is start with the constant term and work your way backwards to figure out the degree. So this is now a constant term, x to the first, x to the second, x to the third, x to the fourth. So my quotient here is x to the fourth plus x cubed plus 3x squared minus 2x minus 6, which should match up with the quotient from my long division problem. Okay? And this remainder, by the way, the remainder is a negative 13 is equal to P of 3 by the remainder theorem. Okay, so there's my quotient. There's my remainder. So it's kind of written in two separate areas here, right? But that's what we were after for that answer. And I think I'm just going to stop and do another example in another video.